Assalamu alaikum wa rahmatullahi wa barakatuh. I welcome all of you to the very first class of the session of the academic session 2021 2022. Today, my dear students, we are going to start the very first chapter of your book, that is chemistry, and the chapter name is periodic table. So, what are the learning objectives of today's class? Today, we are going to have a brief introduction of the chapter itself, that is, what is the chapter about, and why we need this chapter, okay, and a brief history about the chapter. Then we will be going through the salient features, that is, the most important features, functions of the modern periodic table. Okay, so we will be studying the periodic table, how to read the periodic table, how can we identify the elements, okay, to which group they belong, and so on. Then we will be going through the phenomenon periodicity, okay, periodicity, and the last and the final topic will be shells and valency. Shells also known as orbits, so let's begin, let's start our journey. Okay, so introduction. Periodic table. What is periodic table? Periodic table is a tabular arrangement. Tabular arrangement means it's a table organized in a proper sequential manner, organized properly, tabular arrangement of elements. Now this is the key word over here, elements in the increasing order, in the increasing order of atomic number. Okay, again another keyword over here is the atomic number. All of you have a brief idea about elements, so I will be explaining you about these three keywords over here: periodic, elements, and atomic number, for understanding, for comprehending, for grasping the concept of the chapter, and for trying to go into depth that what is the chapter about and why was it prepared, why was it why this chapter came into existence. So the first keyword over here in the definition is periodic. To understand this word, let us take an example. Okay, the very routine which you follow, or which you will be following in the online classes, is first period, second period, the third period, and the fourth period. Suppose in the first period every day you have maths, in the second period you have English, in the third period you have computer, and in the fourth period you have Hindi, suppose. Okay, so these are the four subjects which has been taught to you, which will be taught to you. Suppose I am taking an example, I am not telling that this is the schedule, this is the routine which you will be following, just for the sake of example, for making you understand what is the meaning of periodic. Okay, so every day you are required to study these four subjects, okay, in these four periods. Okay, you can't interchange it. Okay, first period every day math, second period every day English, third period every day computer, fourth period every day Hindi. Okay, so on Monday you had these subjects. So on Tuesday again, in the very first period at 9 a.m. you will be having maths. So after 24 hours, that is after a duration of time, after a span of time, you are returning back, you are repeating the first period again. So this is known, this is what periodic means: a repetition of something, a repetition of a property. When we are talking about the periodic table, we will be dealing with properties of elements. Okay, so something that repeats itself is period. Okay, that's why it's first period, second period, third period, fourth period, because they are repetitive in nature. Every day you will have second period in that stipulated time. Every day you will have first period in the stipulated time, that is 9 a.m. first period, 10 a.m. second period, 11 a.m. third period, and 12 noon the fourth period. Every day you will have these periods get repeated. Okay, so this is what period means, and the very word periodic comes from period, that repeats, okay, on a regular interval of time, on a regular interval. Okay, so when we will be talking about periodic or periodicity in terms in relation to periodic table, we will not be talking about time, okay, rather something that repeats itself at intervals, at regular intervals. It may be position, it may be time. So when you are dealing with the routine which you follow, that is repetition of the periods with respect to time. But when we will be dealing with periodic table, we will be talking about repetition of properties with respect to positions. Okay, you will get everything, just be with me, inshallah. So the first word means repetition of properties in a nutshell, in short. Now let us go to the second key word, that is elements. The second key word, elements. Elements are pure substances, isn't it? They are pure chemical substances made up of same kind of atoms. Okay, so elements are pure substances made up of same kind of atoms. So if I ask you that water and hydrogen, which one is element? Water is made up of hydrogen and oxygen. This is the molecular formula of water. Molecular formula of water is H2O. So the molecular formula itself says you that it is not made up of same kind of atoms, rather it is made up of different kind of atoms, hydrogen and oxygen. So it does not qualify to be an element. But hydrogen, the molecular formula of hydrogen is H2. That means it is made up of only hydrogen atoms. So this qualifies for an element. So now you understood that what elements are. Elements are made up of only same kind of atoms, same kind of particles. And water, they are made up of molecules which contains different kind of atoms. Okay, so water is a compound and hydrogen is element. So the periodic table, if you see the definition over here, is the tabular arrangement of elements. So periodic table is the arrangement of elements only. Okay, pure substances made up of same kind of atoms: hydrogen, helium, lithium, beryllium, boron, and so on. Okay, in the increasing order of atomic number. So how they are arranged? They are not arranged in a haphazard way, in a haphazard manner. Rather, they are arranged in a proper sequence, that is in the increasing order of their atomic number. And atomic number, I hope that you have studied this in class 7 and class 8 as well. Atomic number is equals to the number of protons. The number of protons, that is equals to the number of electrons. Okay, the number of protons, the number of electrons, they equal the atomic number, and it is represented by Z. Okay, so if I take hydrogen, its atomic number is 1. That means it contains 1 electron and it contains only 1 proton in its atom. Okay, that is, the proton will be in the nucleus and the electron will be revolving around the nucleus in shells. So as hydrogen is having 1 electron only, so there will be only 1 shell in which the electron will revolve around it, and in the nucleus of hydrogen you will have only 1 proton. Okay, so I hope you understood the definition. So again I am repeating, periodic table is the arrangement of elements. And what are elements? Pure substances made up of same kind of atoms, like hydrogen, oxygen, nitrogen, not compounds. They are an arrangement of hydrogen elements in the increasing order of atomic number. And you know what atomic number is. Now let us have a brief history that what was the need of periodic table and why do we have to study this. Okay, due to the discovery of a large number of elements, it became very important, it became a need, it became a necessity to arrange them, to tabulate them, to form a table so as to study the elements, so as to study elements easily. Okay, because studying each and every element separately, okay, with a separate yani I would like to say a separate set of books, separate chapters will be very difficult, is very difficult. So the most important reason for the periodic table, for formulating periodic table, was to study the elements easily. Okay, so as to make the study of the elements easier. Now the second point was that the chemists, the scientists, they noticed that the elements are related to each other. The elements are related to each other mathematically, properties wise. Okay, they share similar kind of chemical properties, they undergo similar kind of chemical reactions, they have similar kind of physical properties like boiling, melting, and all of these properties. Okay, so these were the reasons for which the scientists, they formulated the periodic table. So the first reason for making periodic table was to make the study of elements easier. Okay, if all the elements will be in a table, in a page, on a page, it will be much easier to study the elements. And similar and especially when they are arranged, when they are tabulated in a particular way, that is arranged in a particular sequence. Okay, that is meaningful sequence, they are not arranged in a haphazard way. Okay, I will be explaining you how the periodic table is arranged in the next video, inshallah. And the second reason was that the elements were related to each other. That's why they arranged the elements. The elements were related to each other, that is the elements, they have similar kind of properties, they are arranged mathematically, they are related mathematically, and they bear similar kind of chemical and physical properties. So these were the main reasons for which the need of periodic table strike the head of the scientists. Okay, so historically Dobereiner, Newlands, and Mendeleev, although many of the scientists, they tried to arrange the elements, to categorize the elements, to group the elements in the ancient times as well, but these are the forerunners in the field: Dobereiner, Newlands, and Mendeleev. Dobereiner gave a rule of triads. Okay, Newlands, he gave the rule of law of octaves. Okay, and Mendeleev, he said that the properties, that is the chemical and the physical properties, the properties of elements are the periodic functions of atomic masses. Okay, now there is a difference between atomic masses and atomic numbers, okay, which all of you know. Atomic mass is the number, the sum of protons and neutrons in the nucleus of an atom, whereas atomic number is the number of protons that is equal to the number of electrons in an atom. Okay, so the periodic table, the modern periodic table, which we will be learning, which we will be dealing with in the chapter, is based on the rule, the law, that properties of elements are the periodic functions of atomic numbers and not atomic masses. But Mendeleev, he is the first person to form the periodic table, okay, to form the periodic table in a proper way, the first one. Before him, Newlands, he tried to arrange the elements in the increasing order of atomic masses, and he said that the elements, they follow the law of octaves. Law of octave means he tried to arrange eight elements in a row. In a single row, his table, Newland's table, had only 8 elements. Okay, so that's why it is known as octaves. Okay, I'm not going in details because that is not our main concern. Dobereiner, he said that the rule of triad, he said that he took 3 elements. And suppose X, Y and Z, and he said that, and he arranged the elements like this: X, Y, Z. I'm not naming the elements, okay, I'm not naming the elements. Let us suppose X is an element, Y is an element, Z an element. So according to Dobereiner, his table, he said, he arranged the elements likewise. He said that the first element and the second element, if you find out the average of these two elements, you will get the atomic mass. The average of their atomic masses, you will get the atomic mass of Y closer to 8. So that is the average of the atomic masses of X and Z will be approximately equal to the atomic mass of Y. So this is how Dobereiner tried to arrange elements, but he failed to do so in all of the elements, because this is not possible for the set. You cannot make triad, you cannot apply triad rule to each and every element. Okay, so there are 118 known elements to us, 118 known elements to us. Out of this 118, 92 are naturally occurring. 92 are naturally occurring. Okay, and the rest and the remaining are artificial, artificially made. Okay, so these were the forerunners, these were the first scientists who tried to make a proper periodic table. Although they had drawbacks and failures, but they are the forefathers, the most important figures who tried their best to formulate a periodic table. Without them, it was literally impossible for us to have the modern periodic table, which I will be showing you, and inshallah I will be explaining you in the next video. This is the modern periodic table, which you will find in your book on page number 2. Okay, so without them, it was literally impossible for us to have this modern periodic table. So they gave their best, whatever informations they had, they tried, and due to them only, their failures, we have this periodic table in our hands, and it is helping us to gaining the technological advancements. Okay.